going to learn how to graph and write equations of parabolas. Now, I know you already think you probably know a lot about parabolas, and you do from chapter 1, but we're actually going to talk about parabolas that open in all 4 directions, not just up and down. So we've got this new equation. What I want you to take note of is that we have x minus h squared. So that x squared, that's just like your regular parabola that's going to be opening up and down. Now, think back to chapter 1. Parabolas opened up when they were positive. That's the same thing that's going to happen this time. And they're going to open down when they're negative. Now, we don't have any sort of a value, but what we do have to look at is the coefficient here in front of that y. So it's going to be 4 times some p value. We'll talk a little bit more about p in a little while. But what you're looking for is you're going to isolate that squared term, the x squared or y squared. You're going to isolate it, and then you're going to see if it's equal to a positive or a negative value. Positive opening up, negative opening down. Now we also have parabolas this chapter that are going to be opening left and right. So left and right parabolas, those are your horizontal parabolas. Those are going to be dictated by a y squared. So notice here that I have y squared equals 4p times x minus h. So the y squared parabolas are actually going to be opening left and right. So it's going to be opening right when positive. And of course, you guessed it, left when negative. So a parabola is every point is equidistant from the focus and directrix. Now you've never heard about a focus and a directrix, so we'll talk about those in just 1 second. The vertex is the point where the parabola begins. So you know what a vertex is, you know what it looks like. Now we're going to have parabolas that are shifted around, and their vertex is going to be the point h comma k. Something that I want you to take note of is that h is always with x. And k is always with y. So when you have these horizontal parabolas, these parabolas that are opening left and right, that k value is actually what you're seeing first. So when you're writing what that vertex is, that h comma k, you want to make sure that you're taking the x value and putting it in the x coordinate, and the k value and putting it in the y coordinate. So the focus is actually a point that lies inside the parabola. And when I say inside the parabola, I mean inside the mouth of the parabola. So we're talking about a point in there. And then the directrix is a line that lies behind the parabola. It's never going to touch or cross the parabola. It's never going to go through it. The p-value is going to be the distance from the vertex to the focus, or the vertex to the directrix. So that p-value is actually splitting apart the vertex. So you start at the vertex, you go one way to the focus and one way to the directrix. Okay, so we're going to go ahead and look at example 1a, where it's asking us to graph the parabola and then just identify some important information. So the first thing you want to do is make sure that your equation is solved for the squared variable, which in this case it is. You can see y squared equals 16x. So then when we refer back to our list, we know that y squared is going to be opening either left or right, and since this 16 is positive, we're going to go ahead and say that it's opening to the right. Now the next thing we're going to want to do is identify the vertex. So the vertex here is actually going to be at the origin at 0, 0. And the reason why is because we don't have any h or k values. We don't have anything being added or subtracted to the x or the y. Now the way that we're going to find the focus is we're going to have to find our p-value. So the way that you find the p-value is you take the coefficient of x, and that's going to be 16. And we're going to actually set that equal to 4p, because that 4p is the coefficient of our x in our equation. Go ahead and divide by 4 on each side, and we're going to get that p equals 4. Now, my suggestion to you is to go ahead and graph this parabola, and when we ask you to graph the parabolas, really what we're looking for is where's the vertex? So my vertex is here at 0, 0. And then which way is it opening? So we decided that it's opening to the right, so we're going to go ahead and draw this parabola that's opening to the right. So just go ahead and draw a nice parabola. Now my focus is going to be inside the parabola, so inside the mouth of the parabola, and The p-value is telling me how far I want to move. So that p equals 4 means from the vertex, I'm going to move 4 to the right. 1, 2, 3, 4. And I'm going to put a point. So that point right there is my focus. So when I'm asked to identify what the ordered pair is, I'm just going to simply take that ordered pair and write it down. And that ordered pair is 4, 0. Then my directrix is always going to be a line. So your directrix is 4 units in the other direction because your focus and your directrix are equal distance from that vertex. So 1, 2, 3, 4 to the left means I'm going to have this vertical line through -4. Now a vertical line through -4 is going to be an x equals line. So x equals -4. Now, axis of symmetry, we had this when we were doing chapter 1. Axis of symmetry is going to be a line that goes straight through the vertex, and it's always going to be perpendicular to that directrix. So my axis of symmetry is a horizontal line, y equals 0. And that concludes our graphing a horizontal parabola. So now we're going to go ahead and do an example B. First thing I want you to notice is that x squared is not by itself. So you're going to want to go ahead and get that by itself. So we'll take that 1/8 x squared plus y, set it equal to 0, plus y. And we'll go ahead and subtract y from each side. So 1/8 x squared equals -y. Then we're going to go ahead and multiply by 8 on each side. So now I'll have that x squared isolated, and we're going to have a -8y. So this is going to be that parabola. So we know that it's going to open up or down because it's an x squared, and it's specifically going to open down because it's negative. So we can go ahead and write down that it's going to open down. Now the next thing you want to notice is the vertex is going to be at the origin again here, and that's because there's nothing being added or subtracted to those x and y values. It's going to be very obvious when the vertex is not the origin. You'll see that in the next couple of examples. So this parabola is starting at the vertex at 0, 0, and it's opening down. So go ahead and just sketch that graph. That's what we're going to be looking for. And then we can go ahead and find that p-value. So remember, the way you find that p-value is you take the coefficient of your non-squared variable, and we can go ahead and set that equal to 4p. So -8 equals 4p, divide by 4, p equals -2. Remember what p represents. P represents the distance from the vertex to your focus. Your focus is always lying inside the mouth of the parabola, so we're going to go straight down 2 because of that 2 value, and it's inside the parabola. And then we'll go up 2 because my directrix has to be the opposite direction. Remember, your directrix is never going to touch or cross your parabola. It's always in its own little space there. So that when we're trying to identify our focus and our directrix, we're going to go ahead and look at the graph. So my focus is at 0, -2. So we can jot down that point. And then my directrix is a horizontal line now, which is going to be y equals, and that's at +2. Last thing we're going to graph is that axis of symmetry. Remember, it goes straight through the origin, and it's perpendicular to your directrix. So my axis of symmetry here, a vertical line, is going to be x equals, and it's going through 0. Okay, that concludes graphing non-shifted parabolas. Make sure to check out video 2.